guys! Salut les gars! Welcome to Mathman channel. Bienvenue sur la chaîne de Mathman. Today is Basics Math episode 17. Aujourd'hui c'est maths de base épisode 17. So, we will continue to talk about parabolas, and as I said yesterday, I will show you the reciprocal function, but you already know it, indeed. Donc comme je l'ai dit hier, donc je vais continuer de parler des fonctions paraboles et je vais parler de la fonction réciproque, mais en fait vous la connaissez déjà. This function is square root. So the problem is, if you know that x to the square equals 9, you know that x equals 3, because 3 to the power 2 equals 9. Okay, so when you've got x and you go to y equals x to the square, when you make the reverse, you use square root of y. That just is. Okay, but that's not what I want to talk about today. It was just a funny thing. What I want to talk about today is about all the quadratic functions, because there are lots of quadratic functions and there are a lot of properties about this kind of function. But instead of beginning with algebra, let's begin with geometry. So let's have a look on this. Let's use this first. Okay, so let's look at this kind of function. Let's say f of x equals a times x to the square. And let's have a look. If a equals 1, of course, we've got f of x equals x to the square. We don't know. We already know it. Donc si nous avons une fonction du style f de x égale ax carré, que a vaut 1, bon ben ça fait f de x égale x carré, on connaît, on a déjà vu. But let's have a look about what's gonna happen when we move coefficient a. We know when we move coefficient a, that's move the curve. But we always have the same symmetrical axis, and that's just the branch of the parabolas that change. Donc nous avons toujours l'axe de symétrie, c'est seulement les branches de la parabole qui bougent. So multiplying by a number doesn't really change the general property, except of course when a is positive we've got a minimum here, and when a is negative we've got a maximum here. Donc bien sûr, il y a quand même une propriété qui change, c'est que lorsque A est positif, on a un minimum, lorsque A est négatif, on a un maximum. Okay, let's have a look about other operation. But as I said, let's start with the geometric observations. So, for example, if we have a function, let's call this, and let's use the Greek letter alpha. And let's have a look on this kind of function. F of x equals, j of x equals x minus alpha to the square. Oh, what can we observe? We can observe this. Adding or subtracting alpha is moving the curve on the lateral side. Okay? Okay, let's add another number here, and let's call it beta. Okay? And now let's have a look about h of x equals x to the square plus beta. Okay, let's change the color in order to don't confuse. Okay, H will be in orange. Okay, so when I move beta, I can move the parabola vertically. And now let's combine these two kinds of operations. Let's call it t of x equals x minus alpha to the square plus beta. And let's multiply this by a. Okay, so now we can change this, and we can change this, and we can change this. Okay, we don't need to see other function because it's too, yeah, let's just write this. Okay, so now we can observe that this is a symmetrical axis. Okay, let's use the same color as last time. Okay, so we can see when we move the symmetrical axis, we move all the parabola. Okay, and we can see that we can move around along this axis vertically, and we can move the branch like this. Okay, we've got this. Interesting. Now let's have a look about the calculus. So let's take an example. Let's take several examples, and then we will talk about the formula, because there are some calculus and I don't want to disturb you with calculus without doing nothing. So first we have seen f of x equals x to the square. Ok, donc on a vu d'abord f de x égale x carré, ça pas de problème. Là, comme j'ai fait Mumuse avec GeoGebra, bon, j'ai pas traduit, mais vous avez vu. Hein, et de toute façon, sur la partie technique, je traduirai. Bref, we have seen a times x to the square. So, for example, 2 times x to the square. H of x equals x minus 1 to the square. Let's compute this. This kind of guys is called remarkable identities. Remarkable identities, what is that? That's just this. We have used it when we have proved Pythagoras' theorem, so I recommend you to watch the video, but let's do it again. It's not a problem. Just have to use several colors. When we do this, we do this. So that means this guy will multiply this, then this one. So we've got a to the square plus a times b plus this guy will compute with this guy and then with this guy. So we've got b times a plus b to the square. So, because when you multiply a times b, that's the same as b times a, we've got two of them. So we've got this remarkable project. Sorry. A to the square plus 2 times a times b plus b to the square. So if we apply this with a equals x and b equals minus 1, that means x minus 1 to the square equals x to the square plus 2 times x times minus 1 plus minus 1 to the square. So that means x to the square minus 2x plus 1. Okay. So we can say that this is the expand form and this is the factor form. So it's easy and easier to go from factor form to expand form than the reverse. But we see that the reverse part is the most important part. Donc il est plus facile de développer que de factoriser. To expand, c'est développer. Mais en fait, c'est souvent la réciproque qui nous intéresse et c'est ça qui est le plus important, de savoir factoriser. Mais donc, pour savoir factoriser, il faut bien savoir développer. Donc c'est pour ça qu'il est d'abord important de maîtriser le développement. Ok. So, what's the interesting part of this? The interesting part of this is when you've got x minus 1 to the square equals 0, you're good. You can easily solve this kind of problem. You can say that, okay, if the square is equals to 0, that means without the square it's equal to 0, so that means x equals 1. Okay, if we have to solve this kind of problem, x minus 1 to the square equals 4, you can say, okay, I've got an idea. Let's assume x minus 1 equals 2. Okay. You can say that works, because if you get 2 to the square, you get 4. So that works. You can say, hey, x equals 3. Donc vous pouvez résoudre ça en disant, bah oui, si x moins 1 au carré égale 4, on peut choisir x moins 1 égale 2, parce que 2 au carré ça fait 4, et donc du coup x égale 3. But you have to manage with the other part. The other part is x minus 1 equals minus 2, because minus 2 to the square equals 4 also. So you need to not forget that. Donc attention, parce que vous devez aussi traiter le cas x moins 1 égale moins 2, parce que moins 2 au carré est aussi égal à 4. So, sorry, it's minus 1 here. So how can we manage that? We can manage that with this. We've got another trick. If we do a plus b times a minus b. We have this guy and this guy without forgetting the minus here. So that's a to the square minus a times b. Don't forget the minus. And then we've got this guy times this guy and times this guy, but don't forget the minus here. So we've got B plus B times A. Minus B to the square. The point here is A times B is the same as B times A, so minus A times B plus B times A equals 0. So we've got sorry for the color, A to the square minus B to the square. The point here is when you've got x minus 1 to the square equals 4, you have to see it like x minus 1 to the square minus 2 to the square equals 0. Because 2 to the square equals 4. And now you can do the factorization. You can do this by saying that's x minus 1 minus 2, or plus 2 if we take the same way that we have done, times x minus 1 minus 2. This guy is A, and these guys are B. So that's the same. A plus B times A minus B. But we've done on the reverse side. We start with A to the square minus B to the square, and we said that's equals to A plus B times A minus B. And now we can have an easier way to solve this equation. We can compute and say that's x minus 1 plus 2 times x minus 1 minus 2 equals 0. So that's x plus 1, because 2 minus 1 is 1, times x minus 3, because minus 1 minus 2 equals minus 3. And now we have this kind of stuff. Which numbers can get 0 when we make a multiplication? And the answer is only 1. Only 0 can get 0 with a multiplication. Donc réfléchissez à quels sont les nombres qui peuvent vous donner 0 en faisant un produit. Mais en fait, il n'y en a qu'un seul. C'est forcément 0. C'est la seule façon d'obtenir 0 en faisant un produit. So that means either this guy equals 0 or this guy equals 0. You don't have any other solution. You have only two solutions. And now that's normal equation as you know how to solve them. So this solution is x equals minus 1, the same as we found before. And this guy goes to x equals 3, the same as we found before. Donc c'est ce qu'on appelle en français les équations produit nul. On est ramené un produit égal à 0. La seule façon d'obtenir 0 en faisant un produit, c'est de multiplier par 0. Donc en fait, on sépare notre équation en deux sous-équations. Forcément, chacune des deux, l'une des deux doit être égale à 0. Parce que les deux en même temps, c'est pas possible, mais l'une des deux doit être égale à 0. Donc on dit que soit la solution est la solution de la première égale à 0, soit la solution est la solution de la deuxième égale à 0. So we have solved this equation, and we can make an analogy. Et nous pouvons faire une analogie, a very important analogy, très importante analogie. factorize a polynomial, because this guy is called a polynomial. Donc, factoriser un polynôme, parce que ce genre de fonction s'appelle un polynôme, is the same as finding roots. C'est la même chose que de trouver des racines. What are roots? Roots are x of a function that makes this function equals 0. Donc les racines d'une fonction sont les valeurs de x qui rendent la fonction nulle. So we say x is a root of a of x when a of x equals 0. Donc on dit que x est une racine de a de x lorsque a de x est égal à 0. So finding roots is an analog process as factorizing a. Donc trouver les racines de a de x, c'est tout à fait analogue à factoriser a de x. Okay, so now we've got this, we can compute more general formula. Donc maintenant qu'on a ça, on va pouvoir calculer une formule plus générale. Let's say that we have t of x equals a times x to the square plus b times x plus c. Donc, prenons une forme générale ax carré plus bx plus c. We call this kind of function a polynomial of degrees 2. Nous appelons ce genre de fonction un polynôme de degré 2 because the most important power of x is 2. Parce que la puissance la plus importante de x est 2. That's why we called it a quadratic function. C'est pour cela que l'on appelle ça une fonction quadratique. Okay, so first let's assume that a is different of 0. Okay, because if a equals 0, that's not the power of 2. So that won't be interesting. Donc d'abord, on suppose que a est différent de 0, parce que sinon, la puissance, ça serait pas 2, du coup, ça serait pas intéressant. So, we can force a factorization by a. Donc on peut forcer une factorisation par a. So we've got x to the square plus b over a times x plus c over a. Okay, and now that's the most important part. Et maintenant c'est la partie la plus importante. We have to focus on this part. Let's call this a of x equals x to the square plus b over a times x. Et donc maintenant c'est la partie la plus importante, la partie délicate. Considérons ce morceau-là en disant que a de x égale x carré plus b sur a x. And we want to look at the beginning of a to the square plus 2 times a times b. That's what we want to see. Donc on veut le voir comme ceci. C'est ça que l'on veut voir. Because we know this has a factorization. Parce qu'on sait que ceci a une factorisation qui est la suivante, which is a plus b to the square. So let's make some calculation. If we say just this part, we can say we have this minus b to the square, because this guy will come here. So if we say a equals x, and 2 times a times b equals b over a times x. Sorry, here it's not square. Okay. We can say that this, and we can say that b equals okay. So we can write this. Donc on peut écrire equals x plus b over 2 times a to the square minus b over 2 times a to the square. Which is equals x plus b over 2a to the square b square over 4 times a to the square. So now, if we come back to our formula, we've got t of x equals a times x plus b over 2 times a to the square minus b square over 4 times a square plus c over a. And now we can continue to compute. And we've got minus b to the square. Common denominator is 4 times a to the square. So here we've got a, we've got to multiply by 4a. So that's 4 times a times c. And here we go. So let's put this kind of number, delta equals b to the square minus 4 times a times c. So we can put this a times x plus b over 2 times a minus delta over 4 times a to the square. Okay. And we can write this like this. Okay, and we can make two changes. We get alpha equals minus b over 2 times a, and beta equals minus delta over 4 times a. And now we've got what we can call canonical form, which is a times x minus alpha to the square plus beta, the same as we have seen on GeoGebra. This standard form is really convenient. So tomorrow we'll see the purpose of this formulation. So have a nice day and see you tomorrow. Don't be afraid about calculus. If you don't understand on the first view, just make a pause, make a break, and come back and read again, rewatch again, review again, try with the paper, try it several times, try with numbers, and be perseverant, be patient. See you tomorrow.